Good day to all. Today we discuss about mathematics in manufacturing. This is a topic which is useful for defining the objective function and framing the constraint equation for optimize the profit and cost and also the quality aspects in the manufacturing industries or any other industries. Okay, the industries may classified into based on the production. The production may be classified as like continuous production, as like paper cement industries, and the mass production as like wall body manufacturing, and also fabrication, which is boiler manufacturing. Okay, these kind of manufacturing industries are available in nature, but what is the relationship between mathematics and industries? Mathematics are generally used for making a objective function for their objectives and also develop the constraint equation from their availability of raw materials. So that mathematics plays vital role in every field. But in engineering also, mathematics has its own vital role. Okay, so we should aware about what is mathematics in manufacturing industries. Today video discuss about mathematics in manufacturing. That in industries there are four important cases available, which is called as 4M. What is 4M? Men, machine, material, and methods. Okay, here men means number of labor required to operate the machines or methods operations, and also number of materials required to complete the process, and also number of machines required to complete the operations, and the sequence of operations based on the methods available with that machine. Okay, these are all the important thing available with the industries, which is called as 4M. Nowadays 5M also available because 5th is mother environment. Mother environment also plays vital role in product quality achievement. Okay, these are all the basic things required in industry. Today, our presentation considers case study for mathematical formulations in manufacturing industries, which is with respect to tables and the chair manufacturing with carpentry industries. Manufacturer of wooden articles produces tables and chairs. Okay, lot of products are developed by carpentry industries, but today case study concentrates about tables and the chairs. Okay, the objective function, generally all the industries has its objective function as like maximize profit. Okay, maximize profit with the available resources like 4M, men, machine, material, and methods. Okay, here the industrial question is how can we distribute resources for maximizing profit for tables and chairs in the carpentry industry. Okay, then availability, our consideration is carpentry industry. The carpentry industry has the available resources are like 150 units of wood and 75 units of labor. From this, how can we develop the mathematical model? Let's see. Okay, requirements. These two types of inputs are needed to develop the or produce the tables and chairs. Chairs, for number one is wood, number two is labor. From 4M, I consider about men and materials. Okay, for making a table, through 3 units of wood is required and 1 unit of labor required. This is my assumption. And then for producing the chair, I place 2 units of wood, 2 units of labor. Here unit means numbers. Okay. Then creating mathematical model. For creating the mathematical model, we utilize the variables or numerical values. But in engineering, we generally utilize as variables. Variable means x1, x2, x3. Likewise, we may utilize the variables for creating the mathematical model. So that for this case study, I consider x1 and x2. Here, x1 represents table, x2 represents chair. The number of table is 4 means 4 into x1. Number of chair is to be produced is 2 means 2 into x2. Likewise, I frame the mathematical model at the initial stage. Now you are aware about what is x1 and x2 variables. Okay, and then requirements for creating or producing the table. The following requirements are needed, which is wood required for x1 tables 3 units of wood. So that mathematical in terms of mathematical model, I can tell 3 into x1 units. According to labor required for x1 tables, 1 unit of labor is required to produce the table. So that 1 into x1. Similar to same, I developed the basic mathematical model with the for table. Okay, wood required for x2 chairs 2 into x2 units. Labor required for producing x2 chairs is 2 means 2 into x2 units. Likewise, I produce the initial mathematical formulation with regard to respect to requirements. Based on this, framing constraint equations. Constraint means what all the resources I have, what's the limitations I have. Likewise, I frame the equation, which equation is known as constraint. Based on our previous discussions, how to frame the mathematical model, likewise we know. Now, we should aware about how to form the constraint equation. According to the availability slide, you should aware about the total availability of wood is 150 units and the total availability of labor is 75 units. From this, how do I fix the constraint equation? The total wood required for producing the table and the chair is equal to 3x1 plus 2x2 less than or equal to 150, because the total availability of wood in industry is 150 units. Okay, from this I can utilize for producing the table as 3 units of wood and 2 units of wood in chair. Okay, so that I frame the equation as like 3x1 plus 2x2 less than or equal to 150, because I can't utilize the word as much more than 150 units, because my unit has only 150 unit. Similar to same, the total labor required for producing the table and the chair. Here I represent like x1 plus 2x2 less than or equal to 75, because my industry has only 75 units of labors. So that for producing the table, I utilize one labor, and also if I produce the chair means I utilize 2 units of labor. Those things are not exceeds the availability of labor, so that I can frame x1 plus 2x2 less than or equal to 75. And finally, again, what about x1 and x2 variables? Number of tables and chairs cannot be negative, because we can't produce the table as a negative manner in industries, because everything as like positive manner in industries. Number of chairs to be in positive, number of table should be in positive, so that the x1 should be greater than or equal to 0. We may produce the 0 table, but can't produce the negative number of tables and the chairs, so that x1 is greater than or equal to 0, x2 is greater than or equal to 0. Okay, and then framing objective function. Objective function is always deals with the company's profit and the quality of the product and the speed required to complete the travel and the weight of the objects and the waste produced by the industries. Likewise, various objective functions are available in industries. In this case study, we consider only about cost, so that objective function, the production cost is reduced. Okay, and also maximize your profit. Okay, so that two things, cost and the profit are indirect proportional. Okay, production cost is reduced, then the profit is increased or maximized. Okay, so that our objective function is based on the profit is produced by table and chair. Here, what is the sales cost of chair? Chair sales cost is rupees 16. Table sales cost is rupees 20. Now you are aware about what are all the availability with respect to your industry, and also what are all the requirements to produce the chairs and the table. What are the objective function equation? I mean, constraint equation available with your industry. Now you frame the objective function equation with respect to the profit, because your industry always has its own objective function as like maximize its profit, so that the sales cost is important. Okay, so total profit from x1 table and x2 chair can be calculated by z equal to 20 x1 plus 16 x2. Here 20 is the sales cost of table, rupees 16 is the sales cost of chair, I mean profit cost, right? Okay, after that, thus the manufacturer of furniture industry has the mathematical model as like already we framed the objective function equation, so that every industry has the role of maximize their profit, so that maximize z equal to 20x1 plus 16x2 subject to constraint. Now you are aware about how to frame the constraint equation, so that 3x1 plus 2x2 less than or equal to 150 for wood, and also x1 plus 2x2 less than or equal to 75 for labor, where here the x1 should be greater than or equal to 0 and x2 is greater than or equal to 0. Likewise, the materials are utilized for manufacturing the product. Okay, chairs and tables. Okay, Here, why I utilize less than or equal to, because I have 150 units of wood. I can utilize from 150 to less than 150 for creating the chairs, and also less than or equal to for labor. Here I can utilize less than or equal to 75 labors for producing the table and the chair. So that I here utilize the less than or equal to. Why I here use greater than or equal to, because I can't produce less than zero amount of table and chair. It should be more than the zero value. So then only I can get the profit from that industry. Okay, which is a mathematical model formulation in industries. Okay, thank you. And also, you consider our previous video, genetic algorithm. You utilize this mathematical model for optimize for selecting the best value by utilization of that genetic algorithm procedure for identify the best value to produce the chair and the table. Okay, we may utilize the best value of resources, and also we can get the best value of profit from the industry. For the reason, we may utilize the genetic algorithm procedure.